Welcome to the unit on linear relationships. Today's lesson is about understanding and graphing proportional relationships. The goals of today's lesson are that you will be able to graph a proportional relationship from a story. You can use the constant of proportionality or the unit rate to compare the information represented on two graphs. You can graph a proportional relationship from an equation, and you can tell when two graphs are of the same proportional relationship even if the scales are different. So let's start with a story and graphing that. Here we have a story about an ant and a ladybug having a race, and they are going to be represented on this coordinate plane where time is on the x-axis and distance is on the y-axis. So this is x and this is y. And we can see they both start off at the same point, and after 2 seconds the ladybug has travelled 4 centimetres, and after 4 seconds the ladybug has travelled 8 centimetres. We can see here. And so writing those distances and the time as coordinate pairs, we'll say 2 is the x coordinate because it's after 2 seconds, and 4 is the distance because the ladybug has travelled 4 centimetres. And then looking at 4 seconds, because time is on the x-axis, seconds will be represented by the x coordinate. So after 4 seconds, the ladybug will have travelled 8 centimetres. And let's do the same for the ant. After 2 seconds, the ant has travelled 6 centimetres. And after 4 seconds, the ant has travelled 12 centimetres. So this is going to be 4, 12. And there are lines already drawn here, so let's match them up with the bugs. We have the ladybug at 2 seconds has travelled 4 centimetres. So if we go up from 2 here, we'd see we're here. And if we look for further confirmation, at 4 seconds, you can see here the ladybug has travelled 8 centimetres. So the red line here represents the ladybug. And let's look at the ant. At 2 seconds, the ant has travelled 6 centimetres. At 4 seconds, the ant has travelled 12 centimetres. So this purple line here represents the ant. Now let's graph a bug going 3 times faster than the ant. So again, this line represents the ant, and at 1 second, the ant, which is be here, the ant has travelled 3 centimetres. So a bug going 3 times faster than that would have travelled 3 times 3, 9 centimetres. So that's here. And so let's graph this third bug. Like this, and this would be our third bug. So again, I needed a coordinate pair, and starting at the origin at 0, I was able to draw a line between the 2 points then. So write an equation to represent a graph and then draw another graph using the equation but on a different scale. So let's look at our graph here on the left of a line, and we've got a point here at 8, 14. 8 represents the x coordinate and 14 represents the y coordinate. And to write our equation, we need to know the constant of proportionality. So let's draw a table here, x and y. And x is 8 and y is 14. to get our constant of proportionality, we want to know what the y value is when x is equal to 1. So to get from 8 to 1 here, we have to divide 8 by 8. 8 divided by 8 equals 1. So we also have to divide 14 by 8 on the other side here. And so our equation now is y equals kx. Y equals, what's my constant of proportionality? 14 over 8. So y is equal to 14 over 8x is the equation. And now use this to draw the graph with a different scale. So we have the graph here on the right hand side. I'm going to start with an x value of 20. So y equals 14 over 8 times 20. And I'm going to see if I can calculate a y value that I can graph for this. So 14 over 8, I'm going to divide 8 by 4, I get 2, and 20 by 4, I get 5. And then I'm going to divide 2 by 2 and get 1, and 14 by 2, I get 7. So y equals 7 times 5, which is 35. So when x is 20, y is 35. So 20, 35. And I can do the same for x equals 40 to get an extra point. I mean, I have 0, 0 here, so I don't technically need another point. I can draw a line between these two, but I like to double check. So y equals 14 over 8 times 40. And when I do the math there, I get y equals 70. So 40, 70. Okay, so now I have 3 points. I can draw the line. Like this. So that's drawing the line with a different scale based on the equation. So to compare two graphs and see if they represent the same situation or could represent the same situation, let's look at their constant of proportionality. So let's pick a point that's easy to read where two lines intersect. So for example, here. And let's see what our constant of proportionality is. So for x is 10, y is 15. So if x is 1, dividing 10 by 10, I get 1. I have to divide 15 by 10, 15 by 10 to get my y value. And I can say y equals 15 over 10x, or I can simplify that fraction and say y is equal to, I can divide both 15 and 10 by 5, so I get y is equal to 3 over 2x. So I get that there. Now on the graph on the right hand side, I want to pick a nice point. So I've got one here and I've got one here. So again, I can set up my x and y in my table. I'm going to pick the top one. X is 200, y is 300. If x is 1, I divide 200 by 200 to get 1. So I divide 300 by 200 as well. 300 over 200, or I can simplify that down to 3 over 2. And so my equation here now would be y equals 3 over 2x, which is the same as the equation for the other graph. Y is equal to 3 over 2x, y is equal to 3 over 2x. So the graphs could represent the same situation. So recall today's goals. We graphed a proportional relationship about the ant and the ladybug and a third bug. We used the constant of proportionality to compare information represented on two graphs. We graphed a proportional relationship from an equation, and we looked at two graphs which looked different because the scales were different, but when we calculated the constant of proportionality, we saw that they were of the same proportional relationship. And that's the end of today's lesson.